ACT thing I did.
So, what do we do first? If I want to graph this function. So that's find the domain first. Okay? So first thing I want to do is I want to find the domain. So where is this function not defined? Where is it undefined? What? Positive 2, negative 4. So that would make my domain all real numbers, but x cannot equal positive 2 and, that's bad and. X cannot equal negative 4. Okay? That tells me what then?
That your vertical asymptotes are x equals 2 and x equals -4.
So I just take out the not equals parts, and that tells me what my vertical asymptotes are. Okay? How do vertical asymptotes go onto the graph? Dashed lines is the key. Okay? As a vertical dashed line. So we had one at 2. And we had one at negative 4. Okay? What do I do next? Do I have a graph though? So I can't do the range yet. What am I doing, you Ben?
Oh, I was going to say
The y-intercept?
Yeah.
Okay. Oops, that should be black. Okay, so how do I find the y-intercept? I plug in 0 for x, right? Okay, so that's going to be 14 over 0 minus 2 times 0 plus 4. Okay, so 0 minus 2 is negative 2. 0 plus 4 is 4. Negative 2 times positive 4 is, okay, so what is that? Negative, we'll call it negative 7/4, right? What is that? Negative 1 3/4? Okay, so my y-intercept is at the point 0, comma, negative 7/4. Which is right there. Now what? Not quite yet, because I only got 1 point. Plot some other points. Okay. Do we know the horizontal asymptote yet? Just wondering. Wondering if we know it. If not, then we got to plot some points. Do we know it? What is the horizontal asymptote? Give it to me, you pick.
Oh, -2
No. That's the x in, or that's the y-intercept. I'm looking for the horizontal asymptote. 0 is a number. Y equals 0 would be a horizontal asymptote. Why do we know that? Because the numerator is it's a C word. Con it's a constant. Okay? Because the numerator is a constant, it's going to be 0. If the numerator is not a constant, meaning if there's a variable up there, then it's something else. And we've talked about that in the last couple of days. Okay? But because it's a constant, it's y equals 0. Okay? What can I do next? We don't know that yet, though, because we don't have the graph. Okay? So we got to plot some points next then. Okay? So now, when you've got zones, as I like to call this, we've got 3 zones on this one. Okay? So we're going to have to plot some points in these zones. So we need at least 2 points. So let's go -5 and -6 over in that zone. Okay? U6 over here, find me what those 2 y values are. Okay? Then I got to do some more work in this middle part. Okay? So like I've got to do 1, I already got 0. I got to do -1, -2, and -3 in that middle part. Okay? So you 3 in the middle, start working on those 4. Okay? All right? And then over here, I've got to do 3 and 4. Okay? So you 6 over there, do that part. -5, what'd you guys get? 14 thirds? I got 2. I got 2. -6, what did you guys get? 7/8. Okay. Now, did I have to reduce it to 7/8, or could have I left it as 14/16? Just a question. Could have left it, because it's just going right onto the graph then, right? Okay. For 3, what did you guys get for 3? +2. What did you get for 4? 7/8. Same thing then, right? Whoa, that looked like a Z. Okay. Outside, then start working on some of these middle ones too. Okay. So for 1, what did we get for +1? -1, 5, 14 over -5. For -1, I got -3, 14 over -9. For -2, I got 14 over -8. And for -3, 14 over -5. Okay. So, plotting these points then, there, and there, there, and there. It's up a little higher. Okay. And then down in here, we went, so 14 over negative 5, that's what? Almost negative 3? Negative 2.8? And then we went up to there, and then we went to like 1.5, right? And then we came back down, and then we came back down again. Okay, so my function, conjunction, junction, what is your function, should look like that, correct? Yep. Okay. So now from that, can we get a range? All real numbers such that what? Y is greater than 0 and y is less than or equal to negative 14/9, right? Because that's that high point right there. Yes? So it's got a little strip running through the middle of it where it can't reach. So we take that out of the range. Okay? Sound like a plan? So, last couple of days we've been talking about vertical asymptotes. So today, tomorrow, and Monday, we're going to talk about horizontal asymptotes. Okay? So, we're going to shift things vertically now away from the y equals 0. Okay? So, here is my function. F of x equals 1 over x minus 3. Without graphing it, without looking at it, tell me what you know about 1 over x minus 3. What can you tell me about it? Three is a number. The vertical asymptote is x equals 3. Okay? What else can you tell me about it?
Domain of all real numbers and x cannot equal 3.
Okay, because the vertical asymptote is x equals 3, the domain is in all real numbers, x cannot equal 3. Love it. What else? So we said here that this was x equals 3. We said this was all real numbers, but x cannot equal 3. Okay, what else? Is the what? Y equals 0 is the horizontal asymptote. Now you've actually graphed this earlier this week. Okay? And so it has a range of all real numbers except y cannot be 0. Okay? With me? Okay? Now, we're going to shift that into 1 over x minus 3, and then we're going to add 2 to that. So what are we doing with that entire graph? Here, let me show you what that graph looks like. again. 1 over x minus 3. Okay, so there's that graph. Okay. What are we going to do if I add 2 to every output of that? What's going to happen to that graph? Where's it going to go?
Horizontal asymptote is going to shift to positive 2.
What's going to happen to the whole graph?
It's gonna move up.
It's going to move up 2, right? We're going to take this whole graph, I'm going to take this whole picture, and I'm going to lift it up 2. Okay? So, let's see what happens then to that. So now we're going to look at, whoa, tap the brakes, come on now. Let's see what happens to that graph when we add 2 to it. Not yet, not yet, not yet. Okay, so there now is the graph. Oh, come on. Okay, so let me put this back onto here. Oops, now I gotta stop drawing on it. Okay, so there's that. So now we're looking at the red now. So, vertical asymptote of the red. Still x equals 3. So this one didn't change. Horizontal asymptote of the red. So now that goes to y equals 2. Domain of the red, bless you twice. Domain of the red, no change. Range of the red. So all real numbers, but y now cannot equal positive 2. Does that make sense to you? Because vertical asymptotes, that deals with left and right shifts, correct? Horizontal asymptotes, that should change because we moved that whole graph up 2. Domain, that's a left and a right thing. We're moving it straight up and down. Range, that's an up and down thing. Okay? So only when you shift it vertically, only the vertical things get changed. Okay? So, now we said same function, f of x equals 1 over x minus 3. We said our vertical asymptote was x equals 3. We said our horizontal asymptote was y equals 0. We said our domain was all real numbers, but x cannot equal 3. And we said our range was all real numbers, but y cannot equal 0. Okay? Now, what am I doing with that function? Oops. What does this tell me that I'm doing with that function? So, without graphing it, and we'll show the graph here in a minute, without graphing it, is the vertical asymptote of x equals 3 going to change? No. Is the horizontal asymptote of y equals 0 going to change?
Yes.
What's it going to change to?
Y equals -4.
Is the domain going to change? No. Is the range going to change?
Yes.
To what?
All real numbers, y does not equal -4.
let's see what that happens then here now. So I want to go into that one, and I want to go minus 4, enter, okay. Oh, you, up here. Do we agree? Okay. All right. Now, in a utopian world, okay, we would have all of our functions that look like this. Okay? In a utopian world, this would be what all of our functions look like. And we would be so nice and so easy because our vertical asymptotes then would be the lines x equals, out of this, what would our vertical asymptotes be? X equals c. And our horizontal asymptotes would be y equals d. Okay? But unfortunately, we don't live in a utopian society. Okay? Mainly because those kind of functions aren't the easiest to get along with. Okay? We can't do a lot of stuff with them that we want to do. So we write them as a combined type of a function. So what we're basically doing is you are taking 1 over x minus 3 and you're adding it to 2 over 1. Now, if I want to add or subtract fractions, what do I have to do? You got to get a common denominator, right? So what's the common denominator between those two? Joe, common denominator? X minus 3 is our common denominator, yes? Okay. First fraction. Now I've got to adjust my fractions. Remember, if we're adding 2/3 and 3/4, we first find our common denominator, then we adjust each fraction. Does this first fraction need adjusting? No, because it already is in our common denominator. Does that second fraction need adjusting? Yes, I multiplied the denominator by x minus 3. So that means I have to multiply the numerator also by x minus 3. Okay, so if I distribute the 2 into there, then I would get 1 plus 2x minus 6 all over my common denominator of x minus 3. So that I can make that top look like 2x minus 5 all over x minus 3. Okay? And these two functions, g of x here and g of x here, are what we call equivalent. Okay? They're the same, just written differently. Okay? It's like saying 3/4 is 6/8. Okay? They both are the same value, but they're just written a little differently. Okay? And this second way over here, this way is the more common version that you will see of rational functions. Okay? In terms of their graph, if I take this one here now, and on top I go 2x, oh, tap the brakes, child, what the heck is going on there? Okay? If I go on top here, whoa, 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 whoa. Come on now. Sure, it's so easy. If I go, what are you doing? I don't want that to do that. Equals. Equals. What is going on? Things are going all crazy. Katie Wampus. All right, then what we do, we go over to the old, this one, and we go 2x minus 5, and, okay, what this one was plus 2. They end up being the exact same function. Okay? So we did do equivalency. Okay? What I would like you to do now is I would like you to change h of x into the more common form. So our common denominator again was x minus 3. First one doesn't need to be changed. Second one needs to, the numerator needs to be multiplied by x minus 3. So this becomes 1 minus 4x minus negative 12. So that's plus 12. If we take this, if we make this be a positive and that put the negative sign up in there, same kind of a fraction, we get that over x minus 3. So my function then is going to be negative 4x plus 13 all over x minus 3. And then if I look at it on the calculator, which is what the bottom part is saying, there it is. Okay? Okay? And those two are both the same. Okay? So we will continue with this then tomorrow, and then we're gonna go away from this left kind of, we're gonna go away from that kind of function, and we're gonna focus only on this most common kind. Okay?